In this video, we are going to configure storage spaces on a Windows Server 2012 R2 server core machine. And to start off, I'm on my Hyper-V host and I will add a couple of disks to my BCM01 virtual machine. Now first, I want to do a quick rename of the machine because it seems that my naming convention is not really the best when you want to use PowerShell with Hyper-V. So for now I will rename it to BCM01 and then I will rename it back after we are done. And now to add a couple of disks, I will use the following lines, these ones here. I will add 6 disks of 10 gigabytes and these we will treat as SSDs on the virtual machine. And I will add also 8 disks of 20 gigabytes, which will be our HDDs. Let's create these disks. First, the ones that will be treated as SSDs. Also the ones that will be treated as hard disks. And we take all the disks and attach them to the SCSI controller of the virtual machine. So now everything should be the way we said it will, and you can see all the disks. So these are all the disks that we will use for our storage spaces experiment. Let's rename the virtual machine. And now I will move to my DC01 and connect with PowerShell remoting to BCM01 to continue with storage spaces. I'm on DC01 and logged on to BCM01. And let's begin. First, let's get a list of all the physical disks on this machine that can be added to a pool. And you see them here. Now let's also get a list of all the storage pools on this server. And for now we see that we only have one that it's called Primordial. This is not actually a real storage pool, but a way to continue using this abstraction in Windows, even though our disks are not added to a specific pool. So right now we can use the disks independently the way we want, but the idea that Windows is based on storage pools is not lost because this primordial one exists and incorporates all our disks. But this will not happen for long. With the new storage pool command, we can create a new storage pool with this name. And for now I will add only the first disks ordered by size in this storage pool. Let's run the command. And now we can see that the command has finished. Our storage pool is created. Let's get a list. You see that now we have 2 storage pools. And our disks that can be added to a pool now are only the remaining 4. To add additional disks to a pool, you can use this commandlet. You just specify the pool name, you specify the disks, and you also specify the usage for the disks. In this case, I will use them as hot spares, but you will see that we can change this option very easily. Let's add the remaining disks and check it out. We can get, for example, a list of all the disks that are assigned the hot spare role. And we can also set the usage to auto select like the other ones. and I will do this because I don't want to use a hot spare in this example. So now all our disks in the storage pool are set to auto select. And this is the way that we can get a list of the disks that are only in a specific storage pool. And you see what we get here. Now let's move on and get a little closer to also creating some storage tiers. First, let's simplify the view of the disks and get only the information that we want. And here is the disk name, the media type, and the size. You can see that for all our disks, media type is unspecified, so the server doesn't know if it's a HDD or SDD, and the size is in bytes. Now, to use tiers, of course we need SSDs and HDDs. We are on a virtual machine and we don't have that, but we can change the media type to whatever we want, so we can make it look like we have SSDs and HDDs. In production on a real server, I'm pretty sure the disks will be recognized correctly, so I would not recommend you change the media type in your production servers, or maybe also in your test servers if you have hardware servers. But let's see how we can do it. We get a list of disks, and first we only get the disks that will be the SSDs, and we change the media type to SSD. Then for the remaining ones we change it to HDD. Let's run the first command, let's run the second command. Now let's run the get command again. And we are ready to start using storage tiering. But in order to use tiering, we have to create our tiers. And here's how we can do it. With the new storage tier command, we can specify the pool in which we want to create the tier, the name of the tier, and what media type to assign to it, SSD or HDD. We are going to create a fast tier and a slow tier. And in order to get a list of the tiers that you have, this is the command to do it. And it gives you the slow and fast tiers. And here is a cool command that will let you know what size is possible to assign a virtual disk in a specific tier. So if we wanted to make a simple volume only on the slow tier, we could run the first command and it will show us the maximum size that we could assign to our virtual disk, which we can take, if you want to read it a little easier, divided by 1 gigabyte, and it would be 152. And the same, let's say that on the fast tier I want to create a mirror space, and I want to know what is the maximum size that I could assign to that space from the fast tier. I just divide this number by 1 gigabyte and I get 24 gigabytes. So these are the space options that we have at the moment. And of course, since we are using tiering, there is no parity involved, so these are the two possibilities, simple and mirror. Now, before we begin and create our disks, I would like to do one more setting, which is not mandatory, but it's highly recommended also by Microsoft, and this is to set the retire missing physical disks parameter to always on our storage pool. Since we are not using hot spares, whenever a disk has problems, it disappears from the controller, it's taken out or whatever other problem, it will be automatically put in the retired state, and data from the other disks can be rebuilt in case you have extra storage in your pool. We discussed in the last video of the series about the fact that rebuilding data in storage spaces can be done either with hot spares or with extra storage in your pool. Since we are not going to use hot spares, we will use the other option. And I want that the repair to happen automatically, so we are going to run this command. And I'm going to restart the server so the setting can take effect. If you guys know of another solution to for the setting to take effect without a server restart, please let me know. With the server restarted, now we can continue. And before we continue with the PowerShell stuff, I want to also show you in Server Manager how what we did for now looks like. You see, I have BCM01 as a managed server in Server Manager. We can go to disks, and you see that all our disks are not visible in Disk Manager because they are added to our storage pool. But we can go then to storage pools, and we can see the pool that we created. We can see the total capacity and the free space. We can also see all the disks that are added to this pool, the media type, the usage, which is automatic or auto select, like we set it in PowerShell. And from this pane we could, if we wanted to, create virtual disks or storage spaces, how they are called. Very simply by clicking tasks and new virtual disk. But we are going to do all of this with PowerShell. So then let's get back. First, let me show you a couple of commands to create virtual disks without specifying that you want to use tiering. So we can use the new virtual disk command, specify the storage pool, a name for the virtual disk, size. In the provisioning type we have either fin or fixed, and in my last video I explained the difference. Let's make this one a parity disk, and let's actually make it a dual parity disk. So we will have two parity disks instead of one. If you want to make it a normal parity disk, just remove this parameter and you are all set. But let's create it with dual parity. And you see the disk is created. Let's create also a volume for it, so we can place data on it. And that volume is called E. So now we can actually navigate to bcm01/e $. Let's create a test file just so we can have it here. So that was a parity volume. Let's also create a simple volume, which would be called RAID 0 array in a typical RAID array. And basically things are mostly the same. We just say that the resiliency setting is simple. And I also want to make this a fin disk. So create it. Let's assign a volume to this one also. This one is called F. BCM01 F $. We have also a file here. And now let's get to the good stuff. Let's create a mirrored disk that also uses storage tiering. And first, to make the command a little simpler, let's get a reference for our two storage tiers, the fast one and the slow one. And here's the command that we can use. We have to specify our storage pool, which is 1, not 3. The name of the disk will be virtual disk 3. We are going to make it a mirror disk. Since we are going to use tiering, we can only use fixed provisioning. Number of data copies is 3. You can leave it out if you want to create a normal mirror disk with only 2 data copies. We specify the storage tiers that we want our disk to have data on. And we also specify the size that we should assign from each storage tier. So we assign 2 GB from the fast tier and 4 GB from the slow tier. So our disk will have in a total 6 GB. Let's create it. And here's the disk. Let's also assign it a volume. And this is volume G. Let's also navigate on the disk and create a test file. And why not name it test? Now, since this disk is a tiered disk, the data from this disk, as it's being read or written to, will be classified as hot or cold when a specific scheduled task runs. Using that classification, another scheduled task that runs each night at 1 AM will start moving data around based on if it's hot or cold. If it's hot, it puts it on SSD. If it's cold, it either leaves it on HDD or moves it from SSD to HDD, if it's the case. In case you have a specific file that you want always to be on HDD or on SSD, you can pin files to one specific storage tier. And this is the command to do it. Set file storage tier, you specify the file name, and then you specify the storage tier that you want that file to be placed on. And you see that when you assign a space from a tier to a virtual disk, a new tier is created especially for that purpose. Let me show you. With get storage tier, we see that we have 2 new tiers, virtual disk free slow and virtual disk free fast. We are going to pin our test file to the fast tier. Here we go. But just because we did this, nothing will happen in this moment. So what we did here with this command is that we classified this file as always hot. Now we have to wait for the scheduled task that moves data to move this file on the SSD if it's not already there. But check it out, we can get a list of the scheduled tasks that have to do with storage tiering, and these 2 are the ones, initialization and optimization. This one, the first one does the classification of data, the second one does the movement of data. And if we don't want to wait for the optimization, we can run it whenever we want, like for example now. So right now the data is being moved to our SSD tier if it's not already there. Let's take a small break from PowerShell and refresh the view in Server Manager. And here is how things look here. You can see our free volumes, our free virtual disks. Now the space in the storage pool has decreased a little, the free space. And in the disk department, everything is the same, of course. If you want to get in PowerShell a list of your virtual disks, you can use this command, get virtual disk. And you will see the name, the resiliency type, if it's or healthy or not, the operational status, and the size, of course. Let's now try to remove a disk from our virtual machine so we can test also the recovery. So from BCM01, let's remove, for example, the 10th disk. Remove. It's gone. Let's return to the virtual machine. And first, let's run the get physical disk command. And for now, we see that the physical disk is in lost communication and warning, and its usage it is still auto select. And if we get a list of our virtual disks, interesting, the mirror is unaffected, the simple volume of course is detached and unhealthy because it's not resilient to failures, and the parity is incomplete and in warning, but it should still work. So E is the parity, and we still have our file, and not only that, but we can still create files on this disk. F is our simple volume, and this one should not be working anymore because it's failed. And yeah, the mirror one looks fine to me, so great. Here is also how things look from the server manager. We can see that this one is okay, this one is with the red sign and it's not working anymore, it's detached, you see it doesn't have a volume letter anymore, and this one is just in a warning state. And in the list of the physical disks we have of course a disk that now is detached. Let's now add a new disk to our virtual machine. So we simulate that we want now to repair everything and also replace the failed storage. On my hypervisor, let's go to the machine, to the storage controller, and add a new HDD. And since it's only one, we can add it manually. And this will be the name. The size will be 20 gigabytes because we simulated the failure of one of our HDDs. And now the disk is added to the machine. Back on the virtual machine, we can get a list of all the physical disks that can be added to a pool. If we also specify here that we want true. And this is the only one, physical disk 11, the new one that we added, of course. And let's add it to the pool using the server manager, so we can see also from here how we can do it. In Primordial we have a disk, you see here, and in the pool we can add a new physical disk. This is the only one that we can select from the list. We can also specify the usage type. I will leave it on automatic. Media type can only be changed with PowerShell since it's not okay to do it, or let's say Microsoft doesn't encourage you to do it because it should be usually recognized automatically. But anyway, let's add the disk. We added it to the pool. Now we have an extra disk. Let's also really add it. So let's change the media type to HDD. This should do it. And if we get a list of the physical disks, we should have one extra disk here. Now let's also fix the degraded virtual disk, which is very simple. You can just repair virtual disk and you see it repairs it. And the last thing, of course, we have to remove the failed disk from the storage pool. To remove it, the disk first has to be set in the retired state, and usually it's set automatically after all the other spaces are either not possible to get back, like this one, or are repaired. So let's first get a list of all the disks, and they are repaired except the simple one. So in order to remove our failed disk, we first need to delete also the virtual disk too, since this one cannot be repaired. And now we can delete our disk. And if we take a look back in Server Manager, everything should be okay. So now everything is basically back to normal. And that was it for working with storage spaces using PowerShell. I hope you enjoyed the video. Leave a like if you did. Also consider subscribing, and I'll see you in the next video.